All right. Good evening, everyone. Welcome to the Forest Stewardship Managing Vegetation in Fuel Breaks and Reforested Areas webinar. We've got several speakers joining us tonight on this very important topic, and I appreciate all of you for joining us. We're going to go ahead and start with some background information on fuel breaks on the landscape. We're going to start with Katie. Katie, I will let you introduce yourself and then let you go right into your part of the presentation.
Thank you, Kim. Okay, I think I'm an expert at this by now based on how much we've been on Zoom, but let me practice sharing my screen. All right, can you all see that?
Yes.
Okay. Perfect. So, good evening, everyone. My name is Katie Lowe, and I am the statewide coordinator for UC-ANR's Fire Network. But in addition to being a network coordinator, I'm also a fire ecologist, and I research the impacts of fuel reduction treatments like prescribed fire, thinning, and targeted grazing, and forest ecosystems, particularly in the Sierra Nevada region, which is where I think the field tour component of the workshop will take place. I'm also a cooperative extension person, as I mentioned. I'm based out of the Placer County Cooperative Extension Office in Auburn. So if you're ever in the area, feel free to come by and say hi. And before I get started, I want to thank Kim Ingram, Susie Coker, and the rest of the Forest Stewardship team for having me here tonight to chat with you all about fuel breaks. So in the next 25 minutes or so, I'm just going to go over some of the fundamental concepts behind fuel breaks, the role of fuel breaks in forest management, and then lastly, I wanted to share with you all some of the key findings from a recent study my colleagues and I did looking at the impacts of both thyme and wildfire on forest structure within fuel breaks. And I know Kim just said this, but if you have questions during the presentation, prefer if you wait to the end, but if you're dying to ask, I give Kim permission to interrupt me, so thanks. All right, so first let's go over some of the fundamental concepts behind fuel breaks. So first of all, why do we even need fuel breaks or fuel treatments in general? And it's because today our forests have been influenced by a history of fire suppression, fire exclusion, and early timber harvesting. And because of these things, forests are more susceptible to larger, high-severity wildfires, which can have lasting impacts on forest structure and ecosystem health. However, we have fuel reduction treatments like mechanical thinning and prescribed fire that can reduce the risk of wildfire and the negative structural impacts it has to forests. And these treatments do have many benefits, including reducing wildfire impacts on forests, aiding fire suppression efforts, and also restoring forest ecosystems by modifying forest structure. So what's a fuel break? A fuel break or a shaded fuel break is an area treated to reduce the spread of wildfire. And shaded fuel breaks, they're typically a quarter to a half mile wide, and the area is treated with a combination of thinning out live and dead trees or vegetation, and then also treating the surface fuels to remove or reduce the densities of brush or other live plants and other woody fuels. And these fuel breaks, they're often placed in areas like along roads or ridge tops, and their main purpose is really to moderate the behavior in wildfire. So the key phrase is moderate the behavior, not stop an approaching wildfire. And I just want to point out that there is a little difference between a fuel break and a fire break, which maybe some of you have heard of. And a fire break is an area where all of the vegetation is removed down to bare mineral soil, and those are typically refreshed annually before each fire season. And I want to give a quick shout out to my colleague, Tori Norvell, who's a fire advisor. She provided me with these really awesome renderings of what a shaded fuel break could look like in a redwood forest. So as I mentioned, the primary objective of fuel breaks is to change the behavior of an approaching wildfire to really assist suppression efforts. And so, as I mentioned, fuel breaks, they're placed near roads and ridge tops or other natural barriers because they're easily accessible by first responders, and they can provide firefighters with a safe place to take a stand against fires. And even in those more remote locations, like along those more remote ridge lines, fuel breaks are also held often by using aerial retardant drops, and that buys suppression crews more time to reach those remote areas to fight the fire on the ground. And by reducing the surface fuel loads and reducing those tree densities, and in particular, really focusing on removing those smaller diameter trees that could act as ladder fuels, and also increasing the distance between the surface fuels and the live tree crowns, these fuel breaks should result in lower fire intensities, which is the heat released from fire, and also less individual tree torching and lower probabilities of crown fire. However, I want to just insert a little caveat that even under extreme fire weather conditions or fire conditions in general, even your properly designed fuel breaks may not be able to reduce fire behavior as expected if the approaching fire is exhibiting, again, extreme behavior, or if there's long distance ember transport and the firebrands are breaking or flying over the fuel break. So I just want to point your attention to these two pictures on the screen. These were sent to me from my colleagues on the Plumas National Forest. These are some firefighters using a shaded fuel break in Antelope Lake, which is what we'll talk about later, to actually do a burnout operation during the Boulder Complex fire. Notice that they're starting from the road and burning back down into the drainage. All right, so generally the rate of spread can increase as your slope increases. And because of this, fuel break width should also increase with your slope. And generally it's recommended that you increase your fuel break to accommodate with changes in slope. And if you do that, the majority of extending your fuel break should be at the bottom portion of the fuel break. And also you should be mindful of topographic features like dense vegetated drainages, saddle points along ridge lines, canyons, or even narrow valleys. And these are all things that you should be aware of because they can influence fire spread. And then lastly, when it comes to stand density within your treatment units, generally the distance between the crowns of trees is more important than targeting specific tree densities. Typically, you should aim for having at least 10 feet of spacing between the edges of your trees in your units. And then, of course, if you are in steeper slopes, you should increase the spacing between your trees. But if you wanted to keep smaller, more isolated clumps of trees for visual diversity within your fuel break, be mindful to increase the crown spacing between those groups and the nearby individual trees. And again, on the screen here, this is just another rendering of what a shaded fuel break could look like in a redwood forest, given it's on steeper slopes. All right, so now that we went over the fundamental concepts behind fuel breaks, let's talk more about how shaded fuel breaks are used in forest management. So although, again, the objectives of fuel breaks are to facilitate a more effective fire containment, fuel breaks can also promote wildfire resilience by reducing stand densities, retaining larger diameter, more fire-resistant trees, greater crown base heights, and also decreasing the surface and the ladder fuels. And all of these stand level changes will allow for greater overstory survival in treated areas following wildfire. And those who may be unfamiliar, surface fuels are those materials lying on or immediately above the ground, like your sticks, your down logs, or your smaller shrubs. And then your ladder fuels are those live and dead plant materials that are slightly larger, and they can bring fire from the forest floor up to the forest canopy, hence the term ladder. And so before I continue, I want to take a second and explain my definition of resilience in the context of this presentation, because there's so many different definitions there. Here I define resilience as the ability for these forests to accommodate the effects of wildfire and return to a prior structure post-fire. Conifer-dominated forest field treatments, they can have an effective lifespan of about 10 to 20 years. And during this time, the hazardous fire potential can be reduced both within the treatment units and also in their surrounding areas. But ultimately, treatment efficacy depends on both the scale at which the treatments are applied on the landscape and these ability for these units to be maintained over time. So when fuel breaks or fuel treatments in general, you can't just treat the landscape once and walk away. You're in it for the long haul, is what I'm trying to say. So currently, the ability to maintain these field treatments are really limited by things like funding and workforce capacity. And this is all exacerbated by the need for forest managers and fire managers to increase both the pace and scale of field treatments on the landscape. And so ideally, our initial treatments would create forest conditions more conducive to letting unplanned wildfires act as a maintenance treatment, where post-fire conditions would continue to meet those subsequent objectives and provide additional resource benefits, like forest health, for example. However, the current studies that detail the effects of treatments on forest structure and treatment efficacy are based either on shorter study periods or on modeled wildfire projections alone. And so this is why it's important to assess the non-modeled information about the longer-term influences of actual wildfire on field treatment structure and effectiveness. So we can provide land managers who are tasked with increasing the pace and scale of field treatments with valuable information regarding the long-term efficacy of treatments and also the trade-offs for managing for multiple objectives. Okay, so now I want to share with you some of the outcomes from a recent study that I worked on with Ryan Tompkins, who's a cooperative extension forestry advisor in the Northern Sierra, some folks on the Plumas National Forest, and researchers at UC Berkeley. So as I mentioned before, there's not a lot of robust empirical evidence out there assessing treatment performance in different ecosystems or how wildfire impacts treatment efficacy in the future. And so we decided to tackle these research questions in this specific project. And more specifically, we wanted to understand how exposure to wildfire influenced forest structure and treatment effectiveness among shaded field break units that were treated nearly 20 years ago. And so to do this, we use long-term forest monitoring plots within a network of shaded field breaks. And these plots also happen to capture a range of wildfire exposure. So we had plots that hadn't burned, they burned once, or they burned twice in wildfire following the initial plot establishment and treatment application. It was a cool chance for a natural experiment, if you will. And the primary goals of the study were to, one, evaluate how shaded fuel break impacts stand structure and surface fuel loads, both post-treatment and post-wildfire. And then two, determine if fire exposure can in fact extend the effective lifespan of a shaded fuel break. Now, when we evaluate treatment performance, I want to remind folks that context really matters. And what I mean by context is that the ecosystem type, the fire conditions, and even the treatment history all has a role in how treatments perform under wildfires. And so to give more context for this project, our study included treatments in dry, pine-dominated forests on the northeastern side of the Plumas National Forest. And the shaded fuel breaks in our study were near Antelope Lake and in Red Clover Valley. And these fuel breaks were actually established by the Herger-Feinstein Quincy Library Group in the early 2000s. And for those who may be unfamiliar with the Quincy Library Group, it was one of the first larger collaborative multi-agency projects that really aim to tackle landscape scale forest and wildfire resilience in the Sierra Nevada. And so the fuel break units in our project were treated with a combined application of mechanical and hand thinning, and the surface fuels were then treated with prescribed fire. And generally our thinning treatments, they aim to reduce the canopy cover to about 40%, and they really focused on removing, again, the smaller diameter trees that could act as ladder fuels. And then again, we selected treatments based on exposure to wildfire post-treatment. And so some of our antelope border units, as you can see on the map here, were burned in the 2006 Boulder Complex fire, or some of the antelope border units were burned by the 2007 Antelope Complex, and then again in the 2019 Walker fire. And so our red clover units and one antelope border unit did not get exposed to wildfire following the initial treatment application. And I will say that our plots did burn at an average of low to moderate severity. So we found that treatments initially decreased the basal area by an average of 35%, and they increased the size of trees on average by 32%. And for those who may be unfamiliar, basal area is just a common metric foresters use to describe the cross-sectional area of a tree. So basically the initial thinning treatments, they reduce the total area trees occupied in the treatment units while simultaneously removing the smaller trees and leaving the larger diameter ones, which is why the average tree size also increased so much in the 1 year post-treatment measurements. But I want to point out what's neat is that we found that live basal area and live average tree size continued to increase between the 1 year post-treatment and the 20-year post-treatment measurements. And I want to remind folks that during this period, half of our plots experienced 1 or 2 wildfires. And so speaking of fire, we found that wildfire had a greater effect on surface and ground fuels in our project. And we found that units that burned once had about 9% less large woody debris than unburned plots, and units that burned twice had about 70% less large woody debris than unburned plots. And then our plots that burned at low severity had 46% less fine fuel and 76% less stuff than unburned plots, while our plots that burned at an average of moderate severity had about 26% less fine fuel and 77% less stuff than those unburned plots. And now I know I just threw a whole bunch of numbers at all of you, but the most important thing to keep in mind is that generally these results align with others that state that wildfires of low to moderate severity can maintain the lower fuel load that were initially created by the treatments. So treatments also successfully reduce the behavior in the near and long term. And to assess fire behavior, we calculated a metric called the probability of torching, or P-torch, and this is just an assessment of crown fire potential at the stand level. So our average P-torch estimates per plot per measurement year was about 39% pre-treatment, 2% 1 year post-treatment, and 4% 20 years post-treatment. And so although we didn't model fire behavior beyond 2021, I want to note that the average modeled fire behavior remained well below pre-treatment estimates 20 years later, as evident in this graph here on the screen. So how do our results relate to the bigger picture of fire management and wildfire and forest resilience? So overall, the treatments, which again were the combined application of structural thinning and prescribed fire, were not only able to alter forest structure and reduce fire risk in the near term, but they were also able to maintain their efficacy 20 years after the initial thinning treatments were implemented. And so here on the screen, I want to take a couple minutes to walk through this photo series because I do think it's really neat. So these are photos of the 3 different plots within fuel break units by measurement year and fire count. So measurement year are the columns and the rows are fire count. And so all the units that you see here, all the plots rather, were mechanically thinned and they had prescribed fire applied about a year after. And so you see the far left column are the units pre-treatment. The middle column is actually 5 years post-treatment, which actually captures stands. I don't know if you guys can see my mouse here. I hope you can. But this actually captures about 1 year or so after the 2006 Boulder Complex fire. And then this bottom center photo captures a 1 year post Antelope Complex fire. And then the far right column, 20 years post-treatment, which again, for the middle row, that's 15 years post-Boulder fire. And then for the bottom row, that's 2 years post-Walker fire. So I want folks to take a couple seconds and look at these 2 rows, the 1 wildfire and 2 wildfire rows. And I want you to look at how they fare over time and visually what's similar to you all and what's different. I'll give you a couple seconds to think about it. You can maybe type your answer in the chat. For me, what stands out visually is that there is a visual change in overstory and understory stand structure between the pre-treatment and the 5 year post. But then when you look from the 5 year to 20 year, there really isn't a lot of visual change in the overstory. And I think that's really neat. And as someone who has been to these plots and measured the fuels, I know it's a little hard to see, but I was surprised to find that in the 20 years after these treatments, there wasn't a lot of woody fuels on the ground either. And so I think our study underscores findings from other projects that treatments like these that not only modify the forest structure and they reduce forest density, but they also treat the surface fuels. They may last longer and be more useful from a fire management standpoint, especially when you compare them to fuel treatments that only treat surface fuels, which may require more frequent maintenance to be effective. And again, I want to reiterate that the structures and fuel conditions created by these initial treatments allowed these forests to persist through multiple unplanned wildfires. And the reburns of low to moderate severity wildfire enhance not only the longevity of these fuel treatments, but also the ecological resistance by continuing that trend of surface fuel reduction that the initial treatments established, and then forest resilience by maintaining those low density forests. So knowing that wildfire can be used to maintain existing treatments in these drier pine dominated forests can really change the objectives of future treatment implementation and even facilitate the use of managed wildfire in the future. And I want to clarify that by change objectives, I mean that folks should continue to implement treatments to immediately reduce wildfire risk to their communities and valued assets because it's very important. But also, I think we should try and view treatments as a tool to reintroduce beneficial fire into an ecosystem in the long term so that wildfire can continue to maintain the structural conditions that the initial treatments restored. And so finally, I want to leave you all with a couple other takeaway points. The first one being, in the absence of wildfire, you will need to maintain your fuel breaks over time to make sure they continue to be effective. And again, your maintenance schedule will depend on your forest type, your treatment intensity, and other environmental factors. And you can use a number of tools in your toolbox to do this, including prescribed fire, thinning and pile burning, targeted grazing, or herbicide. However, that's all I'm going to say on the maintenance point because Scott and Heather are going to cover those topics more in a little bit. And lastly, I want to encourage you all to think more about land stewardship beyond your shaded fuel break. As I said earlier, many folks across the state, and maybe a few of you or many of you in the Zoom tonight, are putting shaded breaks around your community or properties to protect what you care about, which is important. Clearly, shaded fuel breaks can be a sound strategy for preserving forests and promoting fire resilience. But again, they're only about half a mile wide on average. And when you look at fire and forest management and the challenges that we're facing to really scale this up to the landscape level, to really achieve ambitious treatment targets, we're going to need to start treating the landscape beyond our fuel breaks. So let's start thinking about well-maintained shaded fuel breaks serving as anchor points, not just to facilitate effective suppression operations during a fire, but also to start safely treating the other parts of your property so you can reduce your fire risk, but also restore the health of your forest. All right, thank you so much for listening to my presentation this evening. If we have a couple minutes, I think I can take a few questions.
Thank you, Katie. That was great. If anyone has any questions for Katie, please feel free to take this moment and put them in the chat. Katie, there's one. So far, how well did the fuel breaks moderate fire behavior outside of the fuel break?
Yeah, that's a great question, Chris. Unfortunately, it was not in the scope of our study to assess the behavior of the fire outside of the fuel break. However, I will say that a number of our plots, especially in the Red Clover Valley, they actually reburned in the Dixie Fire in 2021. And so I'm actually going to go up and remeasure some of those plots in a couple weeks to see how they fared. But generally, fuel breaks, as I mentioned, they can moderate fire behavior at least a couple feet outside of the treatment units themselves. But there's other research that shows, out of colleagues from Washington, I believe, that fuel breaks do need to be wider in order to be more effective at preserving more forest outside of their, quarter-mile strip. So.
Any other questions for Katie? All right, well, if you think of any, Katie will be with us the rest of the session, so feel free to put your question in the chat. And with that, I'm going to go ahead and turn it over to Scott. So Scott, you want to introduce yourself and then you can start your presentation.
Perfect. I think you can see my screen. Is that right, Kim?
Yes, you're good.
Well, thank you so much, Kim, for and all of the forestry stewardship team, as well as Susie Coker, for putting this together. And wow, Katie, thank you so much for kind of setting the stage for my talk. So, Katie kind of led perfectly into where we want to be at a landscape scale. And I'm going to hopefully try to give you some of the tools that that I work on for controlling vegetation, different techniques for controlling vegetation on the landscape. So as a quick introduction for myself, my name is Scott Oneto. As Kim said, I am a farm advisor with the University of California Cooperative Extension, and I am in the central part of the Sierra Nevadas. I basically work from El Dorado County south through Amador, Calaveras, and Tuolumne counties. And I also am a weed scientist, so a lot of my research and extension work focuses on establishing or developing weed control strategies for various weedy species or invasive or exotic species. So tonight I was going to share some of the different perspectives that that I have on controlling vegetation in the landscape, and specifically I want to focus on private forest lands, as I think this is kind of the perfect audience for that. And I guess I'll just start with a few different slides of different pictures of this is sort of I think what makes it unique and also very interesting is that I think private landowners across the state have this complexity of different types of landscapes that they are trying to manage, and it kind of runs the gamut from pictures such as this where you may have a oak woodland with very dense understory of shrubs and various forb species. Also, of course, we have established conifer forest with an understory of maybe it's mostly bare clover or a mixed component of various shrub species and different forbs and grasses. And then we may have something like this where I think I get a lot of questions in terms of when we get some of these more invasive exotic brush species that move into some of our different plant communities. This was a picture outside of Georgetown that I took where we basically have, large populations of Scotch broom that have invaded some of these timber forests. And of course, we're all probably very familiar with the fuel laddering that these shrubs can basically serve in terms of moving, excuse me, forest fires and also just carrying the fires up into canopies. I think another question that I often get asked is about the shrub component and shrub islands in mixed conifers or in these sort of plant communities. You can see some conifers in the back here, and so this is just an island of manzanita that this particular landowner wanted to basically reduce. It was basically encroaching in on the timber stand. And then, of course, we have other woody plants or woody weeds that people might want to control as well. In this case, we've got a fairly large stand of blackberries. So that kind of just sets the stage of, the complexity of the different types of plants that people are trying to address, the size and the scale, whether you have 1 acre, 5 acres, 20 acres, or 1,000 acres, your goals might be similar, but they also might be very different. And so, some of the things that I like to start on when speaking with private landowners on how to control woody vegetation is really about starting on just talking about what their goals are in terms of what is the desired outcome. And those could be both short-term desired outcomes, but also long-term desired outcomes. And how we get to each of those might be, we might use different tools. And so, identifying what you want that landscape to look like. And again, it might look completely different for two different landowners that have very similar looking properties. The second question that I often ask is, what plants do you want to control? And then also, are there any certain plants that you want to maintain and promote as part of that landscape? I think as we look to, finding that balance, there are certain plants that may be beneficial for having as part of that ecosystem that can serve as, food for browsing animals. It could serve as nectar for pollinators, habitat for birds, berries for wildlife. All of those kinds of things need to be taken into account. And then lastly, how might you control or how might your control strategies change over time? And again, just thinking about all of those different tools that you have in the toolbox, which ones you might use immediately versus which ones you might use in year 2 or year 3 or year 5 or year 10, again, to get to those desired outcomes. So I like to think of vegetation management control strategies as this very large toolbox. And as Katie kind of alluded to, there's lots and lots of tools in that toolbox. And I kind of break them up into these 3 sort of broad umbrellas in terms of developing what I call an integrated weed management plan. And I kind of just broadly put those tools into these sort of 3 silos, one of them being mechanical. So mechanical would basically be anything that you would use as a physical method to cause injury or death to that vegetation. And I'll talk about all the different types of mechanical treatments here in a second. Cultural would be the second sort of silo or bucket to put these in. And that would be where we manipulate the environment in a way where it basically leads to the suppression or control of vegetation. And then lastly, I'll touch on some chemical strategies where in that instance, we're using herbicides, whether they be synthetic or conventional herbicides or even organic herbicides to control that vegetation. So let's go ahead and maybe start with some of the mechanical controls. And I'm sure many of you are familiar with this type of equipment. This is basically mastication equipment where they can very quickly go through and basically munch or chip that woody debris, whether it be small diameter trees or brush or woody species, basically into wood chips and mulch. And it just scatters that debris on the ground. And of course, there's lots and lots of different types of equipment that kind of fall into this category, but they all basically do the same thing. And I kind of consider these sort of the dinosaurs or the brontosauruses of vegetation management in terms of these things. It's remarkable at how fast and quickly these types of machines can operate on the landscape and the number of acres they can accomplish in a day or a period of time. So I guess some of the advantages I would say is that, these things are very quick. They remove, all sorts of size of vegetation from small diameter shrubs to actually quite large size diameter trees. Often I would say they minimize soil disturbance because they are usually they're on track equipment. So they're usually pretty good in terms of minimizing any type of soil disturbance. And then again, all that material is ground up into to biomass and into chips that spread out on the landscape. But with that, I guess that you could also say there's some disadvantages to this. This is I would say definitely specialized equipment. Most private landowners don't have these, sitting in their barns or, they're sitting out back that they have access to. So you can sometimes rent them, but often you are hiring a contractor to do this kind of work. And so it can be costly. And the other big thing about this is you often see a lot of resprouting of, again, trees and shrubs. Mostly the oaks are the resprouters, but again, madrones and manzanita, many of the brush species have a tendency to resprout after mastication treatments. If you've never seen a before and after picture, this is just one that I had seen that I think does a really good job illustrating the before and after of using mastication equipment. So you can kind of just see just how well they do in terms of creating that very open stand that kind of Katie was showing in many of her slides with developing sort of those larger shaded fuel breaks. Another really large type of a piece of equipment that is also often used for, again, kind of doing some of this fuel reduction and vegetation clearing is what I would just call brush piling, using either, a front loader on a cat, as you can see here in the upper right picture, or even using just a tractor with a bucket, or even with a grapple bucket. These can be pretty effective at just, again, consolidating those fuels and that vegetation, that woody biomass into piles that can then be dealt with. Some of the advantages of these treatments, I would say, again, removes pretty large woody vegetation. Again, it can be a fairly quick treatment. I would say this one, unlike the other one, this one might be more easily done by an owner operator. You might have access to, a tractor, or, borrow one from a neighbor or a friend. And I would say, if you have that equipment, I would say it's probably fairly inexpensive. So it's mostly, if you're doing it yourself, it's just your time, fuel, and just the regular maintenance and wear and tear on that machine. Some of the disadvantages with this is, I would say, definitely it's higher soil disturbance, depending on, the slope, the site characteristics. If you're actually, grading and moving soil material as you're moving that brush debris, whether or not you're on a very steep slope or not, all of those things kind of take into account how much soil disturbance there might be. As in with the mastication, again, we often see a lot of resprouts unless you're actually coming through and pulling, using that equipment to actually pull the root biome, basically the root structures out of the ground. You will often see a lot of resprouting with this too. And then you also have to contend with the biomass. So you're often making large brush piles that you then need to burn. So a little bit smaller equipment would be something like the brush cutters, and there's lots and lots of different types of equipment out there that kind of fall into this category. I think these work great for sort of smaller scale projects, where you may have either, thinner brush species or thinner vegetation that you need to control, and maybe not on quite a larger scale. Again, this could be done by an owner, again, either renting equipment or purchasing it. You can also, again, you can put metal rotary blades on some of the weed eaters, and that serves as a similar purpose. You just have to be super careful with those, not to cause, again, either any personal injury or hitting rocks. And so timing of these kinds of equipment are really important. Again, same with the disadvantages from some of the previous ones. Again, because you're often just shearing off and causing some mechanical injury, you often will see resprouting of some of these brushy species. And I would say this is a much slower treatment than the previous two mentioned. Another mechanical treatment, again, you can kind of see I'm scaling down in terms of, the size of the equipment. This is, I would say, just kind of throw in the general term of lopping. And, you could probably envision all sorts of different tools that you could use to lop woody vegetation. Either, a chainsaw. In this case, you could be using loppers, several pole saws. You could be using all sorts of different types of equipment to basically, again, kind of bring that biomass down or eliminate the top portion of that plant. Again, this is typically, I would say, best used for either single stem trees, or if you have multiple stem shrubs, that they be fairly large. It makes it much more difficult when you're trying to do something like this treatment on something like blackberries, where you have many multi-stems. You can do it, but it just makes it much more difficult. So again, it's more easily done on plants that just have a single stem or a few stems. Again, this is something that anybody can do. It's fairly inexpensive. The equipment is inexpensive. It's just mostly time, which is probably the biggest disadvantage. Also, we see resprouts with this. And again, we have to contend with that biomass. We're basically removing the top portion of the plant from the root structure, and we have to deal with that. So often we're, putting it in piles and burning it, or, chipping it. This is a tool that I'm not sure if you've seen before. This is a weed wrench, and there's many different companies that sell tools like this. But again, this is, again, a small scale operation where you have, maybe a few dozen or a few hundred brush plants that you need to remove, and you want to physically remove all of them. This would be potentially a tool that you could use. Basically, it has a grapple at the bottom of the tool that latches or grabs onto the base of the plant. And so this could either work for a single stemmed tree, or a single stemmed, or if it is a multi-stemmed trunk, you can grab onto one of them. And it basically has an opening of about 2 to 3 inches. So anything under that 2 to 3 inches diameter, you can grab onto, and then basically just using leverage, as you can see in the pictures here, you basically just pull back and it'll extract the whole entire plant up out of the surface of the soil. So very effective. It's again, owner operator, you buy these. We actually, as a lot of cooperative extension offices or even agricultural departments across the state, have these that we loan out for landowners. Yeah, if you're interested in getting more information on these, you can certainly contact myself, and I can try to get you more information. Again, this is a fairly slow technique, but and then you have to also contend with that biomass, but very selective, and also very effective, as you don't get that resprouting because you are pulling the whole plant out. Another, I guess, mechanical technique that I would kind of throw in the mechanical toolbox or silo is grazing. And I kind of throw it in the mechanical because, again, we're using the mouths of animals to basically do the same thing, right? We're basically causing some sort of a mechanical injury to that plant to either reduce the biomass or to actually physically control it. And I think there's been a lot of interest. It's been super exciting over the last, I'd say, 10 years to see how much resurgence in grazing there has been for fuel reduction projects, and specifically to see this sort of contract grazing business just explode. And so I think when it comes to animals, a couple of things to keep in mind is that, having, probably the first and foremost thing is have the right animal for the particular job. The 3 probably primary species that are used for grazing for fuel reductions would be, of course, cattle, goats, and sheep. And all of the 3 of those animals, graze very differently or browse very differently. And so they have very different appetites in terms of what their desired forage species are. And so, if you have a lot of grasses and forbs, I would say, lean towards to livestock, to cattle. But if you're looking at, eliminating more brush species, then you're probably going to be looking at more of like goats or sheep. And so, yeah, I think those are probably the big things to think about when it comes to, which kinds of animals to choose. And of course, there's advantages and disadvantages of using animals. Certainly I would say some of the advantages are that, some of you may have animals and you're already doing this, which is you probably already know all the added benefits that come along with doing this. But if you don't, you can, contract graze. You can actually, hire folks to come out and set up the fencing and bring in the water, and they bring in livestock guardian dogs. They do basically all of the infrastructure. It's also, I would say, fairly less expensive than some of those other, larger treatments that I shared with either, brush piling with the large equipment or even mastication. And I would say it's fairly minimal soil disturbance with most of these animals. They're fairly light on the landscape as a whole. And then some of the disadvantages, again, because we're just, browsing this material, we're basically just causing mechanical injury. These plants are going to regrow. And so as with any of these treatments that I've talked about, multiple treatments are often required. And yeah, these often take a little bit longer than some of the other treatments using livestock. Moving on to cultural control. So again, this is where we're kind of manipulating the environment to suppress or control plants. And, I kind of throw probably the biggest one I think of when I think of, well, there's two that fall into this category, but this one, I see as sort of almost like a freebie. If you do mastication work, as I mentioned, it's not removing that biomass off site. We're basically just changing the structure of that biomass. So you're taking, all of that biomass that's either in the form of shrubs or small or medium-sized trees, and you're basically displacing or moving that biomass down to the forest floor. And as a result of that, you basically have this free cultural strategy that got implemented as a result of that, which is basically mulch. And I would say, mulching is great in the sense that, it in terms of weed control or vegetation management, it does a couple of different things. One, often this stuff is fairly thick. I mean, I see projects where you might have 3, 4, 5, or even 6 inches of mulch after one of these mastication projects. And as a result, you're doing a lot of shading of that forest floor where the seeds are, either desirable or undesirable seeds. It's basically shading those seeds out. And so you get a lot less just germination in general from these mastication projects. The one thing, you also see some other added benefits in terms of, providing soil protection and increasing water infiltration. But the one thing that I do often see is, some of the really yucky invasive weeds, they, being weeds, they, take advantage of, opportunities. And in some cases, you can see weeds move into some of these areas that have been masticated. So, after treatments, as with anything, right, we have to do maintenance. And so going in and, again, pulling some tools out of the toolbox, if you do see non-desirable plants coming up, using those tools effectively to control them is, of course, something you just have to do. The other, of course, big one in this bucket, of course, would be the use of fire or burning. And I think, Katie did a fabulous job highlighting the importance of broad scale burning and prescribed fire in terms of how it can make this resilient landscape. And so moving in that direction, I think, is probably a lot of our goals. But getting there, I think sometimes we have to use some of these different tools to get us to a point where we might be able to use prescribed fire. And so when I think of fire, I kind of think of it as a couple of different ways that we might use it on the landscape for vegetation management control. The first, of course, as Katie highlighted and really talked about, was the use of prescribed fire and broadcast burning. But the other ones I would also put in there, of course, would be the pile burning, which, you know, I kind of talked about, where we would need to use pile burning based on some of those other mechanical control strategies where we're basically having to deal with that biomass. And then the other one that I'll show a picture of here in a second is individual plant flaming. And so if maybe you may not be something on your radar yet, so maybe that'll be a new tool. As with a lot of, you know, these different tools, I put timing as a critical component for the use of fire, just because it is probably, out of all of, or many of the tools that we have in the toolbox, timing is probably the most critical for that, for the use of fire. In terms of advantages and disadvantages, you know, I kind of struggle with this one because, you know, I say it can be inexpensive, but at the same time, you know, if you're trying to implement a broadcast prescribed fire, you may be looking at different costs. And then, you know, some of the other advantages I see is that it does recycle nutrients, and there's probably several other benefits that many of the folks that are on this call that do a lot of prescribed fire can better articulate. And then again, with some of the disadvantages, I would say we often see, again, resprouting, and also I see the germination of some undesirables as well as desirables. But again, maintenance after a fire is often needed to make sure you get what you want on that landscape. So just a picture of a brush pile burn. Again, probably all familiar with that. And then this is a flaming technique, and I'll just see if I can start this video here and you can take it. So in this case, we're just using a propane torch, and we're not trying to ignite the actual vegetation. We're just basically passing very high intensive heat over the plants to basically cause those plant cells to rust. We're basically causing contact burn of those leaves to basically cause some localized death. So that's what burning looks like if you've never seen that before. So I'm going to move on over to control, to chemical control. And I guess I'll start off with just saying there's a lot of chemicals that are out there. And this is a very, very short list of ones that I often see used, I guess you could say, in what I would classify as non-crop weed control. So, you know, kind of outside of, you know, general farming agriculture. These are probably some of the most common active ingredients that folks would use, or if you hired a pest control business to come in and do some woody or vegetation management, these might be some of the herbicides that they might use, or you might use. And then there are just a couple of them that are over the counter available, and so I thought I would just touch on those just in case you're not familiar with them, till you talk a little bit about the pros and cons of those individual ones. But before I do that, I think I'll just start with a couple of definitions when it comes to herbicides, just so we're all on the same page when we talk about some of the differences between the three that I'm going to talk about. The first, and this is you know, kind of a new set of definitions that I have been adding because I've been getting a lot more interest from folks on the use of organic herbicides and their efficacy in controlling vegetation. And so, you know, just to be able to put that in context, an organic herbicide is basically a pesticide or a material that is derived from some naturally occurring sources. And so that's by definition what some of these organic herbicides are. And I'll talk about some more of them here in a little bit. And then the others all kind of fall in this conventional or synthetic sort of bucket. And those are basically herbicides or materials that have been formulated or manufactured by some chemical process. And then the next set of definitions I want to just talk about is whether or not an herbicide has any type of selectivity. And what I mean by that is, does it affect just a group of plants, or is it broad spectrum and basically anything it comes in contact with, it could potentially kill? So basically non-selective herbicides kill everything. So they kill all plant types. Selective herbicides actually target a particular type of plant. And most commonly, I would say we have herbicides that are selective towards what we call broadleaf plants. So anything that has a broadleaf. So in this case, any sort of brush or woody plant or any forb, anything basically that's not a grass would be kind of in that category. So that we have broadleaf selective herbicides, so they basically target those broadleaf plants and then leave grasses alone. And conversely, we have herbicides that target just grasses, so they would basically kill grasses and leave broadleaf plants alone. So that's one of the sort of categories that we sometimes will look for if somebody is trying to maybe want to promote, say, perennial grasses in their timber stand. You would potentially want to, maybe if you needed or had to use an herbicide, you would want to choose something that potentially was selective at leaving grasses alone and targeting those broadleaf brush species. So that's just kind of, to put it in context, that's kind of how those two work. And then lastly, post-emergent versus pre-emergent. So post-emergent herbicides are those herbicides or materials that only work on actively growing plants. And so they have no soil activity and they don't control the seeds in the soil. Versus pre-emergent herbicides, those actually are applied basically to the soil, bare ground, with the notion that you will have germination occurring. And so these materials would, of course, control those weed seeds as they germinate. So some herbicides have both post-emergent and pre-emergent activity. Many of the ones that we use only have post-emergent activity and don't have any soil activity. So again, just some things to make note of as you're considering, if you are considering an herbicide, what those terms mean. So I'll just cover three herbicides, again, just for the sake of time, but also these are the ones that you would actually, if you went to, anywhere, as a homeowner or a landowner, if you went to a local nursery or a plant center or a big box store or a hardware store, these are typically the three active ingredients that you would have access to. And so the first one is glyphosate. I'm sure many of you have heard this active ingredient before. It's a very commonly used herbicide in all sorts of systems. It is classified as a post-emergent herbicide, so it only kills emergent plants. So again, it doesn't have that pre-emergent, so no soil activity. It's also non-selective. So basically, if it comes in contact with green plants, whether they're broadleaves, or they're grasses, whether they're trees, whether they're shrubs, it'll have activity and potentially injure or kill that plant. And then it's available in many different concentrations, as well as many different formulations. And I just put a spattering of them on the screen here, just to show some of the differences. There are ones that are ready to use. There's ones that have 18% active ingredient, and then you can get up to ones that actually have 41 or even 56% active ingredient. So there's lots and lots of different formulations and concentrations available. The second one would be triclopyr, and this is also a post-emergent herbicide, so only kills, again, plants that are actively growing. But this one is selective. So this is as I mentioned before, we have those herbicides that have some selectivity. This is one of those herbicides that is selective at only targeting broadleaf plants. So it would kill trees and shrubs and other, forbs that you may have, but it would leave grasses alone in general. There's a couple of different formulations, and I'll mention them just because I think it is important for the sake of how you use this herbicide. There's one called the amine formulation, which basically is a water-soluble formulation of this herbicide. And the importance about pointing this out is that because it's water-soluble, the only way this particular herbicide can enter a plant is through green leaf tissue, or applying it directly to the vascular cambium if you were to do like a cut stump treatment. And so that's really important. If you're looking at products, you would see the word triclopyr and then you would see the word amine in that very, very small print. That would tell you that this is water soluble. It has to be applied to the leaves or directly to the cambium. The other formulation is an ester formulation, which basically means it's an oil soluble formulation. And again, on the label in that small font, it'll say triclopyr and it'll say ester. And what's important about that is that this can not only enter the plant through the leaves or directly if you apply it to the cambium, but it can also enter through the bark. So that could be very important for, if you want to make directed applications of this herbicide, to a particular plant, you may only have to treat the bark, as I'll show you here in just a couple of minutes. And then as with the other products, again, I mentioned this one because it is available in lots of different formulations over the counter. And it's also sold as what is classified as an agricultural chemical. And so you could get a permit to buy, other formulations and larger quantities of this particular product. And then the third one I'll mention is imazapyr. And what makes this one different is it does have both post and pre-emergent activity. So again, it has the ability to kill actively growing plants, but it also has soil activity to prevent seed germination. It's also non-selective. So again, it kills both broadleaf plants and grasses, and it's available over the counter in just a couple of different formulations or a couple of different products. These two probably being the most common ones that I see, RM43, which is called Total Vegetation Control. And then there's a lot of products or different companies that sell products that say something like Ground Clear, and that usually has imazapyr in it. So I want to just spend a couple of minutes talking about some different application techniques for how we might treat vegetation on the landscape, in particularly the sort of woody vegetation. Because I think there's this sort of, I guess, sort of the general consensus that, we go out and we, douse the plants with an herbicide, and that certainly does happen. And that's one way to do it. But I think there's a lot of other more directed application techniques that I think it's important for landowners to know about, whether or not they want to use an herbicide or not. Knowing, again, what those tools in the toolbox could look like may help make an informed decision. So I break it up into two sort of categories. The first being what I kind of throw in as basically foliar application. So you're directing the herbicide to the canopy of the plant. And then the other one is a directed application where you're making a very strategic application of that herbicide. And so I'll show just a couple of examples of some of these. The first being just that foliar, that general foliar application. And I think this is kind of where, we often see, where you're spraying a plant, the directions on the label say, spray to wet, sprayed so that the leaves are fully covered, but before the point of runoff. That's usually what the language says on these labels. And so in general, these are, fairly low concentration, but high application volumes. So, you might be applying, sometimes the labels will say 1 quart to the acre, or maybe applied at a 1 or 2% solution. And then you apply that at often in the range of anywhere from 20 to 30 gallons of solution per acre. And that's not even on the low end. I've seen some people that do spot sprays or broadcast applications, they might be applying 100 gallons of spray solution to the acre. But basically in that sort of scenario, you can kind of picture, lots of volume, whether it's 20 gallons or 100 gallons of spray solution treated in an individual acre. And you have some herbicide in that, and you're basically spraying all of that foliage to wet. So that's, one type of treatment method. One that I have been, I would say, I guess, if I was to use the word, I guess, advocating, instead of doing these kind of foliar applications, if you need to use an herbicide and direct it to the foliage, one that I've been sort of testing for several years now is what I call the low volume or drizzle application. Unlike the last one where it's kind of considered low concentration, high volume, this is just the opposite. So we're doing very low volumes, but a more concentrated solution. And so, in this case, you might be, rather than applying 1 or 2% solution, now we're doing 8 or 10%. But rather than applying it at 20 or 30 gallons of spray solution to the entire acre, now we're doing it a fraction of that. Now we're applying it at 5 gallons to the acre. And so by doing that, we're putting basically just a few droplets on an individual leaf rather than trying to spray that whole entire foliage to wet. And one of the reasons that I think this could be advantageous for sort of these wildland forestry settings is that, if you are reliant on a backpack, if you're spraying 30 gallons of spray solution to the acre, you have to go back and fill up your backpack 8 times to just treat a single acre. If you're doing this treatment, if you've got a 4-gallon backpack, now you're basically almost treating a whole entire acre with just that one single load. And so just to give you an idea of what that looks like, this is a drizzle application that I made on some blackberries. And so you can kind of see, I'm just kind of trying to drizzle that spray solution on the entire canopy, not trying to spray it all to wet, but just trying to distribute those large droplets over the entire canopy. So if you're looking at total pesticide applied on a per acre basis, they work out to be exactly the same. And I'll show you an example of that in a second. So you're still applying the same amount of pesticide. You're just doing it in a different format. So that's kind of what that spray pattern droplet looks like. You can hopefully see in this picture some of the droplets. This is after the material dried. I grabbed this sample just to show you what the spray pattern of what that drizzle looks like. Now, going kind of to the more stem directed techniques, this is the first one that I wanted to just highlight, and this is called basal bark. If you're not familiar with this is basically where we apply a concentrated application just to the bottom portion, typically about the bottom 12 inches of the stem, whether it be a tree or a shrub. You just treat that bottom 12-inch portion of it. And again, that herbicide can translocate or move into the vascular tissue where it can then translocate and cause death to that tree. The important thing that I'll make a note of on this is that, again, I mentioned those 2 formulations of triclopyr, the amine and ester formulation. If you are going to do a basal bark application and you are using triclopyr, you have to use that ester formulation, that oil-soluble formulation, so it can actually penetrate that bark. Imazapyr also works good as this treatment, but glyphosate does not because it is water-soluble. Another, again, directed stem application technique that I would recommend would be what is called the cut stump. And so just using either a handsaw or a chainsaw, cutting those trees or shrubs down, and then applying the herbicide just to the cambium or that outer ring of the plant to again cause death, and that'll prevent it from basically resprouting. And for that, any three of those herbicides that I highlighted before could be used for that kind of a treatment. So I want to just finish up with, I guess, promoting a project that I've been working on for this past, I guess, 8 months or so. And this is going to be a workshop that's going to be coming up. And I know this was promoted as the field tour portion of this webinar series. And so this is the flyer for it. I could probably, I don't know if well, we could ask after it, but I don't know if this got sent to everyone, or if not, I can drop the flyer in the actual chat pod. But the map, the QR code listed here is the map or the directions to that workshop. It's basically in Pine Grove in Amador County. So hopefully you can make it on September 16th. It's from 9 to 11 on a Saturday morning. I will put in a plug. We are having one 3 days prior to that, Wednesday the 13th in the late afternoon from 3 to 5 at the same location. We're going to be covering the same stuff both of those days. But so yeah, if you can come, that would be great. And what we're basically the concept, or what this workshop is on, is we're going to be showcasing roughly 34 different treatments on how to control brush and vegetation in a shaded fuel break. So this is the Mitchell Mine fuel break, which was basically started in 2018. It got done in 2022, but it's a 393 acre or 10-mile long shaded fuel break that runs in Amador County, just north of Highway 88 or Pine Grove. And we have been working with the Amador Resource Conservation District and the Amador Fire Safe Council to basically put in a demonstration to teach and show private landowners and agency personnel and others that are interested what some of these different treatments look like on the landscape in terms of controlling or managing that regrowth after mastication or after the installation of that fuel break. So this is what the site kind of looks like. This is, again, it's basically about 3 years after the installation of that fuel break at this particular site. So we're getting a lot of brush regrowth, a lot of manzanita, a lot of ceanothus, a lot of madrone, a lot of oak, all resprouting. Some of it's about 2, 3, even some of it's as tall as 6 or 7 feet tall. And so we basically put in this demonstration. It runs perfectly right down the middle of what is Lupe Road. So Lupe Road is this road that kind of runs right down the middle of your screen here. And on either side of Lupe Road, we put in these half-acre blocks, basically to, again, kind of show how these different treatments compare to one another. I mean, we want to be able to just try everything, and people can decide for themselves, oh, this is what this looks like, this is what that looks like. Maybe I want to try this on my property. So again, as I mentioned, there's 35 treatments in total. It's about 17 acres in size. And again, each one is about a half acre in size. But what's nice is you can just walk down the road with the map, and you can see well into all of the different treatments to see how effective they are. So just to give you a real quick summary of what some of the treatments are, we're doing several different mechanical treatments. So a lot of the treatments that I kind of highlighted earlier, grazing with goats, flaming, lopping using an herbicide, all of those kinds of things we have implemented. We also have 29 different herbicide treatments. That includes 10 different active ingredients. So I showed you 3 common ones, but we actually are using 10 different ones because there's some new materials, there's other materials that I just didn't have time to cover. And so we have 10 different active ingredients, 3 organic herbicides, which I was super excited to try them out. And with each one of these, we're applying them at different rates. We're tank mixing some of them, and we're applying them doing those different application techniques. So both foliar and as a broadcast treatment, but also doing that drizzle or that low volume. And then also we are doing some in the spring as a spring treatment and some as a fall to show whether or not there's any differences between a spring or a fall treatment with some of those techniques. So I'll just finish up with a couple of just before and afters. We actually went out to the site today to just get some pictures. Just as an example, this is a triclopyr. So I mentioned that active ingredient triclopyr. This is a triclopyr foliar application. The actual product is called Garlon 4 Ultra. This is the ester formulation. It was applied at a 2% foliar application. So basically sprayed as a foliar, that low concentration, higher volume. We were applying it basically at 25 gallons of spray solution to the acre. And so you can kind of get a sense of, the investment in these treatments. We're going to do a cost analysis as part of this. So it took us 44 minutes to spray this half-acre plot. We used 10 gallons of total spray solution. We used 25 ounces of total herbicide, 12.5 ounces of total surfactant, which is this methylated seed oil. And we're going to come up with the exact dollar sign. But right now I'm calling it $2 signs because it took us a long time to make this treatment. Conversely, this is the same active ingredient. This is Garlon 4, but this is as a drizzle treatment. So again, this is that sort of low volume, higher concentration, still using the same exact amount of herbicide, 25 ounces. But again, to treat that half acre, it took us only 11 minutes versus nearly an hour. And we only used 2.5 gallons of spray solution. So basically a half a backpack. And so hopefully this will be some helpful information. We'll have all of this information on signage at every single treatment so people can get a sense of, look at it, see how it compared. We actually have some control plots that were not treated, so you can see what the untreated looks like versus some of these treated plots. So I think this is my last slide. So again, just a map to the workshop, and I guess I'll take any questions if there is time. If not, thank you so much for your time. And again, reach out to me anytime if you have any questions or comments. Thanks.
Thanks, Scott. I think we have time for one question. So of the pesticides you talked about, should you avoid certain of them near riparian habitats?
Sure. Yeah, I would, so the label is the law. And some of these active ingredients that I mentioned, depending on the formulation or the actual product you buy, some of them can be used to have aquatic, some of them have aquatic registration. So you actually apply them up to water's edge or even over water. Others, you have to stay completely away from water totally. So it really depends on which individual product and the actual formulation of that product. So yeah.
So what's that wording on the label, Scott, that people should look at?
Yeah, so right when you purchase that product, at the very, very opening statement of that label, it's going to tell you what the site uses are. So it'll say you can use it in non-crop areas, industrial sites, roadways, conifer plantations. If it doesn't list water there, don't use it around any flowing water. And it'll actually usually even have further down in the label, it'll have an environmental section, and it'll say, it'll typically stay there really specifically, keep at high water mark or keep it 100 feet or 100 yards from water. It'll say specifically right there. If it does have an aquatic label, again, at that very introductory statement, it'll say all of the sites and it'll list, you can use it in ponds, you can use it in flowing water systems. It'll list it all right there.
Great. Thanks, Scott.
Sure.
All right. Well, if you have any other questions for Scott, please go ahead and put them in the chat. And so I'm going to turn it over to our last speaker tonight, Heather Morrison. Heather, you want to introduce yourself and take it away?
Hello, everybody. My name's Heather Morrison, and I am a licensed pest control advisor, agricultural licensed pest control advisor. And I am also a registered professional forester. And so I saw that comment come through about the water use of herbicides around water. And herbicides are definitely, including organic herbicides, have toxicity. And so it's really important, like Scott said, to read the label. You just don't go out there and start spraying things. And I think that's one of the reasons why we talk about pest control advisors, is that we can provide the good information off of that label to help people understand what they need to be spraying, because you don't want to underspray and you don't want to overspray, because there's definitely different weeds that have different that have, can I say this, that are more or less susceptible to different percentages of rates, not rates per acre, but like a 2%, like French broom, for example. You can kill it with 2%, but you couldn't kill huckleberry with 2%. So hiring a pest control advisor is really a smart thing to do. And you can actually get a pest control recommendation, which is what a pest control advisor would provide, through a lot of the herbicide dealers. So if you are unable to hire a PCA that's knowledgeable in weeds, because pest control advisors, there's several different categories. And so my category, I am a weed specialist, but I also can do growth regulators, which I've never done. I passed that part of the test, but I've never actually used hormones or growth regulators, but I have used pretty knowledgeable in weeds. But we can, you can hire, when you if you were to buy an herbicide from an herbicide dealer, they can provide that pest control recommendation. So why would you use a PCA? Yeah, so that you get the right dosage for the right plant. Additionally, PCAs, as part of the licensing process, we are encouraged to use integrated pest management, which is, like Scott was saying, is all the different tools in the toolbox. There are so many different tools, and a lot of times using them in combination with one another makes for a stronger result, a more successful result, than if you were to just use one of those tools. For example, the use of fire along with herbicides can be extremely successful with French broom, which is really difficult to treat if you're just doing it with herbicide or fire alone. And a lot of times fire can actually exacerbate a lot of the invasive plant issues, because a lot of these invasive plants love fire to germinate. So you can use fire to help increase the germination of a bad plant, and then whack it with herbicide, and boom, you've really cut down that population. So another reason why pest control advisors are important is that we can read that label and help you be aware of some of the hazards, like drift. For example, Garlon 4, which is a triclopyr, is really can be very very bad for grapes. And so whenever I've worked in Napa County, I'm very thoughtful of that, because from the literature that I've read, grapes can be very susceptible, and they can if the perfect conditions exist, you could really hurt someone else's crops out there if you're not careful. Additionally, you would want to know how far you can be away from water, or how close, how close can you get. The proper personal protective equipment, that's very, very important. What should you be wearing? And we should, you just don't go out there and just start spraying weeds. There's definitely PPE, and that is listed on the label. Additionally, we would have on the pest control, our recommendation, we would have the dosage rate, which, like I was saying, so for example, I'm looking at one here. Sorry, I don't have a PowerPoint. I didn't know I should make one. I would have if I was thinking I wasn't. So on this particular pest control recommendation, we're using Garland 4, and we're in a forested environment, and so I wasn't worried about there being any kind of drift on adjacent crops. But in this case, I'm using a 5% solution, and this the weed that we're controlling is in this case we're controlling French broom. And then additionally, the surfactant. So like Scott said, he was using methylated seed oil. There's also other types of surfactants, and the surfactant is kind of like a soap that helps the herbicides sit on the plant and then soak into the plant. And then also, if you're spraying wide areas, we might add on the recommendation that you might want to use a dye, which would help you see where you have sprayed. And then also the type of the type of treatment. Are you doing a hack, which is where you hack the tree before it's fallen down, or do you cut the tree and then you wait for the sprouts, or how tall do the sprouts need to be in order to be successfully treated? And so these are all things that pest control advisors know. We are licensed by the Department of Pesticide Regulation, and there's different licenses. There's besides the pest control advisors, there's the QALs and the QACs, which are qualified applicator certificates and licenses. And basically, if you are going out, and if I was to go out and spray on somebody's property, I would need to have a QAC. And if I was going to supervise the licensed crew, I would have to have a QAL. But a PCA, I just would write the recommendation. And a lot of PCAs are both. We have to take we have to do continuing education classes every 2 years, and so it's pretty tough. We have to have about 40 hours of CE hours every 2 years, which is difficult to get because the DPR is very careful about what they how many hours they will give for talks. And so every talk needs to have some sort of either herbicide or integrated pest management discussion. Talking about, I know that Scott was mentioning organic herbicides and over-the-counter herbicides. So over-the-counter herbicides, you can get those as organic as well. And personally, I have tried to use organic herbicides, and one of the things that I found is that they are just not systemic, which means that they don't travel to the root system. I haven't found one yet that will go into the root system and kill the plant. It just usually burns the top part off, really similar to the flaming tool that he was demonstrating on his video. It's great for just getting rid of that top part, but a lot of times plants just will come back. And so if you're willing to continually have to treat, then organic may be what you want to do. But I personally think that if you go the route of the traditional synthetic herbicides, that you treat it once and then you don't have to come back in and treat it again, unless it's an invasive plant, because then you still have something, you have just a constant, invasive plants. They're really good at continuing to be there. There's also, I was looking at the DPR website today and to try to familiarize myself with a little bit of the other licenses. And there's also what was called a private applicator certificate, which as an individual property owner working on your own property in a non-agriculture setting, you're definitely free to apply these herbicides yourself. But once an individual is using it to produce an agriculture commodity, so if you're out there and if you are a timber owner and you are actively out there spraying, you need to have a private applicator certificate through the DPR. Most of the time, I always recommend folks to go ahead and hire a pest control business to do this sort of work, and let them worry about ordering the chemicals and worrying about the PPE and understanding the dosages and the solutions. And dealing with the backpack sprayers and all of the issues that can arise. But definitely, if you've got small areas that you can treat, I would you could go ahead and try and purchase your own herbicide and treat it yourself and add the proper surfactant. So let's see.
Heather, quick question along those lines. So are there certain applications that would require a PCA as opposed to, you just mentioned, on smaller property owners, maybe with smaller weed issues might be able to handle it themselves, but if there's some application that absolutely requires the PCA?
From what my experience is, a lot of these government assistance programs like this California Forest Improvement Program and the Environmental Quality Incentive Program, the EQIP and the CFIP programs, they require a PCA to go out there and write the recommendation in order for them to get funding to do the work on the ground. But no, there isn't. There really isn't. But I think that I think it's a smart thing to do. It's kind of like you go to the doctor to get treated instead of trying to treat yourself, unless it's like a cold or something. So like I said, the other thing, when we look at the label, there's other little details like the reentry interval. A lot of these herbicides definitely have a reentry interval where if you treat that field, it's considered a field, even if it's a fuel break, you have a period of time where you cannot go out into that field, and it varies between different herbicides. It can be, in this case, this is Garland 4, it's a 12-hour reentry interval after you were the last portion, the last hour that you treated it, you have to stay out for 12 hours. So also the timing of the application, Scott was talking about timing, and timing is really important in I would say everything in, like he was talking about grazing, which I know it's not my part, but grazing, I've seen the timing of grazing been bad when they come in and they graze it in October when the grasses are all dead, and so then they get about 2 weeks of fire fuels reduction before the rains come. And so I think timing is really important for all of the tools, and especially in herbicide treatment. And that's one of the things on this pest control recommendation is, what time are we going to do it? Because depending on the time of the year, you might use a different herbicide. So yes, like glyphosate might work at one time of the year, but at a different time of the year, no, you want to use a different type of herbicide depending upon the weed that you're trying to treat, because they're not the tree is or the plant is not actively growing, or it's actively growing, it's going to it's not going to be able to absorb the herbicide as effectively or whatnot. So depending on the timing, that's another thing that the pest control advisors would take into account when recommending herbicides, because they are not all equal. So, and just like Scott said, he's doing all of these great trials, which is how we understand, and because of the continuing education that we have to go to these types of workshops so that we can better understand the different types of weeds and how to treat them effectively. Like I said, at what time of the year and what's the dosage rate, et cetera, et cetera. I don't know if I have anything more to say. Oh, yes, I do. So the County Agriculture Commission is basically who we have to register with. And so if you were looking for a list of PCAs, you would go to your agriculture commissioner, and they're usually associated with the UC office in each particular county. Or I think you can also go online and also get that information. But
okay.
Anyway, thank you.
Well, we do have a couple questions though for you. So a participant has asked, where can that dye be purchased that lets you know where you've sprayed?
So You can purchase, I've seen the dye at Tractor Supply, but it's really expensive. And so it's better just to go through like a dealer to get like a big jug, because you do end up using a lot of it. And again, depending on the colors, you don't want to use blue for French broom because you can't see it. So you'd want to use the colors that are going to be appropriate for whatever it is that you're spraying. But yeah, you can get that. I've seen it in quart sizes at Tractor Supply, but Tractor Supply is expensive, and you can go online and buy a lot of this stuff as well, and they can ship it.
Great, thanks, Heather.
You're welcome.
Any other questions for Heather or Scott or Katie? All right. Well, thank you to our presenters. I'm going to go ahead and stop the recording. Much appreciated.